Hello everybody, this is Unit 2, the Periodic Table and Trends, Section 1, Types of Elements and Reactivity. So you do not need to have guided notes out for this. You will be writing this down in your notebook, preferably with Cornell notes if you know how to do that. If not, no big deal, but you should get the major pieces of information from this. And you will also probably want to have your periodic table out while you do this. So the first thing we want to discuss is metallic character, which is essentially how metal-like an atom is. And we know from our previous lessons that pretty much the entire left side of the periodic table is metals for the most part. So it would make sense if metals are more metal-like on the left side. But if we're talking about all elements overall, they have more metallic character going from right to left and from top to bottom. So that would mean that francium has the most metal-like characteristics and that fluorine or helium, this corner, has the least. So when I'm talking about metallic character, I'm talking about the properties of metals, which are these properties here. They're good conductors of heat and electricity. That's why we use them for like plumbing and electrical wiring and things like that. Well, I guess plumbing's not one of them, but that's why we would use it for electrical things like wires and stuff like that. They're mostly solid at room temperature. The only exception to that rule would be mercury. Hg is a liquid at room temperature. They can have a lot of really diverse properties. They can be different colors, they can be different densities, things like that. But some of the common properties are that they are ductile and malleable. Ductile means that it can be pulled into a long, thin wire, and that is why we can use it for wiring for electricity. And malleable means that it can be pounded down into a thin sheet, meaning that it's moldable. We can put it in a bunch of different structures and configurations. That's why metal is really good for like housing and for a lot of different objects and things that need to be in different shapes. And then we have luster, which is how shiny it is. If you actually look at all the metals on the periodic table, most of the metals are gray and shiny, with the exception of some of our like coppery colored ones like that. But most of them are pretty much just gray and shiny. So in terms of metallic character, that would mean that francium would be the best conductor of heat and electricity, and it would be really, really shiny, and it would be really, really malleable, and it would be really, really ductile, and so on and so forth. Then we have our nonmetals, which are a little bit more diverse, because even though there's only a few nonmetals, they can have a bunch of different types of physical properties, but the things they all have in common is that they're bad conductors of heat and electricity. We're going to talk about why coming up in next unit, but just know that they are. And then most of them are gases. Our noble gases are a lot of them. Then we get like the whole top row, nitrogen, oxygen, that kind of stuff. Those are all gases, with the exception of bromine being a liquid. And then we have a couple of solids like sulfur and phosphorus. So the state of matter is a little bit different in that they're not all the same thing, but they are all bad at conducting heat and electricity. Then we have our metalloids, which are just really confused and they don't know what they want to be. But metalloids are a combo of metals and nonmetals. They possess properties of both. They're found along that staircase that we talked about last unit, and we consider them to be semiconductors of electricity. They're used in electronics specifically because they conduct electricity in some instances and not in others, and that they're really good conductors at some points and not others. So if we use just metals in our electronics, then it would fry our electronics and it wouldn't work anymore. That's why we use semiconductors, and that's why Silicon Valley is such a big thing, because we had a bunch of silicone and then we got really good at making computer chips and stuff. And then our last one, we're going to do a lab on this, but it's all about reactivity, and it's a chemical property that is the ability to perform chemical reactions. So metals, if we're talking about metals specifically, as you move down and to the left, reactivity increases. Where francium is the furthest down and to the left, meaning it's going to be the most reactive. A lot of the transition metals up in here are relatively non-reactive, like gold is relatively non-reactive. And then for our non-metals, they've got a slightly different trend. Trying to erase things. There we go. Our non-metals have a slightly different trend, and as you move up and to the right with our non-metals, we have fluorine here, which is the most reactive. And we'll talk about why coming up in this unit, but just know that it is. Fluorine is the most reactive nonmetal, francium is the most reactive metal, and then we have our noble gases over here, and we know that our noble gases are non-reactive because they already have a full octet. So at this point we've gone through the properties. In future lessons we're going to talk about trends and why these properties exist, but you should be starting to be familiar with the fact that we can use the periodic table for a ton of really important information, and it's actually really fascinating how well it fits together. So woohoo, periodic table!